We saw what is QoS. We saw layer 2 QoS. We also saw an introduction to IP precedence and DSCP, which is used in layer 3 to set weightage to the classified traffic. Both IP precedence and DSCP, differentiated service code point, are used in layer 3 marking, but the more granular marking options are available in DSCP. The reason is DSCP uses 6 bits, whereas IP precedence uses only 3. Right, so for both, you have some bits like 3 and 6, and both are compatible each other. And depending on your requirement, you may choose to use IP precedence or DSCP. If you have more classified traffic, then the 3-bit, which is giving you only 7 different level of marking weightage, won't be sufficient. Whereas with DSCP, you get 64 different levels of marking, which is also explained here. You see the structure of IP precedence is 3-bit, and we call it as type of service bit. Zero to 7, so totally 8 different weightage levels or priority levels or different marking levels. Higher value is high priority. So DSCP has got two different classification, EF and AF. EF's marked traffics are highly safe packets. They never get dropped. The highest weightage given for traffic is EF, expedited forwarding. Compared to EF, AFs are less prioritized. In AF also we have various other classifications like AF11, AF21, AF31, AF41, which we are going to see later in coming slides. IP precedence is older one. DSCP is the real one which is needed for today's network, the real marking. Because in today's network, we got a lot of applications, and each application needs different levels of priority, different levels of marking. For that, you need more number of bits. DSCP has got that bits 0 to 63 levels of marking. They are both compatible. The first 3-bit of DSCP is what IP precedence. So if a router has got IP precedence, other router has got DSCP, they are compatible. For a small network with less number of applications, you may go with IP precedence, this legacy method for basic prioritization, which has got only 3-bit and 0 to 7 level of marking. Whereas for the real modern network, which has got various applications in network, various type of traffics, you really need this granular control. That too, you want to have different weightage for the same traffic in different level, which is nothing but per hop behavior. For this, DSCP is the best one compared to IP precedence. Now, expedite forwarding, I already told you, this is the one which is supreme marking. And the packets marked with this will never get dropped because there are other markings like AF 11, 21, 31, and 41. If there is a congestion, only AF 11 gets dropped first. If still the congestion, then it will drop AF 21, and that is how it goes from low to high. The highest priority is EF. The next highest is AF 41. And when you don't configure any QoS for some traffic, they all will go as best effort. Best effort is the default QoS. Even before AF11 getting dropped during the congestion, the best efforts will get dropped. The one with no markings. Best effort is no markings, no QoS. So during the congestion, this is the one which is going to be dropped first, the one with no markings. And this is the important page which I would like to explain you. You see these classes, we already saw classes like AF11, 21, 31, and 41. When there is a congestion, AF11 gets dropped, not the 21. But within the class, you again have different drop probabilities, 1, 2, and 3. Within the class 1, if you notice, there is 1, 1, 1, 2, 1, 3. 1, 1 has got high weightage than 1, 3. So if it needs to get dropped, which one will get dropped? Not the one with the high weightage, the opposite. This has got high weightage than this. So this will get dropped first. High drop. So within the class, the bigger number is bad. But between the class, smaller number is bad. That needs to get dropped. Is this clear? Hmm. Hmm. Yeah. So let's assume we have a big interface. Some traffics are coming with AF13. Some are coming with AF22, AF21, and some are coming with AF33, AF31. Some are coming with AF43, 41. Now, when the congestion happens, to avoid congestion, definitely it is going to drop some traffic if you have enabled policing. Policing is to drop excess baggage, excess traffic. So during the congestion time, which one should I drop? Among this 1, 2, 3, 4, 5, 6, 7 different type of marked traffic coming in, what do you think will get dropped first? Forty-three, 41, 13, 22, 21, 33, 31. First, what will get dropped? Exactly. All AF13 packet will be dropped until the congestion goes down. If congestion is not there, even AF13 will be going without any problem. But if there is a congestion, till the congestion goes down, it will drop AF13. If still, after dropping all AF13, congestion continues, then which one? No. We are talking about dropping, not prioritizing. Correct. 22 will get dropped. All the traffics of 13 and 22 will be dropped. Even after dropping all 13 and 22, if the congestion continues, next what? See, this is the clue. First, all one should drop. All that begins with one, which you have already told. Now, all two should drop. In that two, 22 will drop first, and then what will drop? 21 will drop next. You are not saying this one. What about this 21? This will get dropped, and then this will get dropped. Yeah, this will get dropped, and then this will get dropped. After that, this will get dropped because compared to 33 and 31, this has got less importance. Yeah, not okay. Yes, sir. No, you tell me, understand and tell me. Listen, listen. When you are seeing two or three, which one is important for us? Three is important. Two is less important, correct? When you see in this, which one is uh, three important? So two have to drop, no? All twos should drop. Only then it will go to three. Okay, fine. We have dropped 22, 21. First it dropped 13. Still the congestion is there. Then whether to drop 22 or 21, it will say I'll drop 22. Fine. Then it says I will drop 21. And still if the congestion continues, what is next? Not 31, it is 33. Because when you see vertically, the top one is important, the bottom one is high drop. 33 will be dropped. And when that is all dropped, still if the congestion happens, then this will be dropped. And now you see these things will never get dropped. This AF11 thing will never get dropped. Hmm. Exactly. Now you understood the table. Now let's try to understand this binary marking. Here if you see it is AF11. But if you just take this the whole thing 6 bit 001010, this is 1, 2, 4, 8, 16, 32. Then you will say 8 plus 2 is 11. That is fine here, but it won't come same way for this one. You see, for this one, I'm writing here 1100. So this looks like 8 plus 4 is 12. Okay, AF12. This is also okay, but let's see this one. 8 plus 4 plus, this one is not coming as you expect. You see here these 3 bits are on. What is the actual total you should get? 14, correct? But what is written here? 13. Which means the way that we read is not correct. How we should read this? You should not take all 6 bits together. You should only take this 3 separate and then the other 3 separate. In this other 3 also you should not consider this. So now you see this is 1. Do you understand why 1? This place is 1. This place is 2. This place is 4. I said, see this, consider this 3 separate. What do you get? 1. And what is the value of this? 1 plus 2? That is why you see 1, 3. Now let us see this one. What is the value of this? 1. And then I told you, don't consider this last 0. What is the value of this place? 2. So it is 1, 2. You understood? Not okay. Yes or no? Let me. Okay. Now here also 1. This is 1. Now let us see this one. 2 plus 1 is 3. And this is 2. Now let us see this one. 4, 3. You understand now how it is written? All right. No problem. Take your own time. You see, we can do 2 different type of congestion management. When there is a congestion, I can manage the congestion by using a rough method. Another one is smooth method. The rough method is policing. Smooth method is shaping. Rough method is policing. And smooth method is shaping. Yeah, why do I call policing as rough method? You see, when there is a excess of traffic, what do we mean by excess of traffic? When there is a traffic which is beyond, no. When there is a traffic beyond committed, let's say 15 kg, you can bring if you want to board a flight. You can bring up to 15 kg. That is what the domestic airliners will, most of the country will say. Most of the country they will say 15 kg. You can bring 15 kg. What if I bring 20 kg? Two things you can do. One is rough way, another one is smooth way. The rough way is asking them to drop that 5 kg. So what this guy will do, he will stop dropping 5 kg of this AF13. He will drop less important luggage, 5 kg, will be forced to remove from your bag. That is policing. When the excess traffic comes beyond the committed rate, those traffics are dropped, thrown out. That is traffic shaping. Sorry, policing. Traffic shaping is they say, okay, see, you customer, listen, we want to serve everyone. This is a small chartered flight. You have brought excess baggage. If everyone is having 15 kg, then we cannot carry your luggage. You see, for each passenger 15 kg, we have calculated that's the maximum the flight can accommodate. This is a chartered flight. You don't have enough space. You see in the cargo. So we are taking this excess 5 kg from your luggage, and we will send through some other cargo flight. We are not forcing you to drop. You see, we are shaping you. We are still going to bring your luggage. We are going to give you the luggage, but after small delay. Up to 15 kg, you don't have any problem. You can carry with you. We are not going to delay that 15 kg. We are just going to delay only the excess. Only the excess we are going to delay. Only the excess. Because you are not supposed to bring more than 15, you have brought it. Anyway, no problem. We are not rough. We want to deal this in a smooth way. We promise you to give you the luggage, but in the next flight. A big flight is coming with more space. We'll put that excess 5 kg in that flight, and it will reach you maybe after 2 hours of your arrival time. You arrive at 10 o'clock in your hometown, it will come at 12 o'clock noon. You need to wait and collect and go, or we will come and drop you in your doorstep, free of cost. But for the excess 5 kg, you have to pay. Per kg, like 2,000 rupees, like 10,000, you have to pay. Oh, what? 5 kg? For 5 kg, should I pay 10,000? This is 5 kg of my old clothes. No, man, for this 10,000, I'll buy new clothes that you can put it in garbage. That's your wish. So, traffic policing is when the excess packets are dropped without consideration. That is policing. Traffic shaping is when an excess packets come, they are placed in a slow queue instead of putting in the same fast queue. Because it is excess, it no need a high priority. Put them in a low priority queue so that it will be sent later. It will be sent later. Put it in the low priority queue. Only those excess, you just put it, remark it, and put it in the low priority queue so that it can be sent later. Shaping is just slowing down the traffic, excess traffic. Policing is dropping the excess traffic. Did you get this point? Read for yourself, please. Yeah, within that bandwidth limit. Five MB only we have committed for traffic coming from VLAN 10. So we want to make sure that VLAN 10 won't exceed more than 5 MB. We keep a check, 5 MB bandwidth. If anything comes more than that, we force it to drop. All right. This is just configuration example. In the class map, I'm calling the access list. Yeah. And then you can see here, we are setting the policing limit. Policing is what? Police 5 MB. This is 5 MB in kilobits. Okay. 5 MB. And then excess burst, you are allowing, okay. Let us allow 0.8. Point or 8 KB. Excess, no problem. Just, like if someone is bringing 16 kg, they're supposed to carry only 5 kg in the aeroplane, let's say. If he's bringing 16 kg or 15.5, 500 grams extra, they will allow you. It's okay. 500 gram only, no, you can, no problem, you can go. That is what this one. Little more, okay, you be liberal. You just allow 8 KB extra. 5 meg is what allowed, but you are allowing 5.8. If it is confirmed, you transmit. If it exceeds, drop. Dropping is what? Policing. You're dropping the excess, which is this one again. You are emphasizing. It is not 8,000 to 10,000. It is 8,000 and 8,000 only. Means 8 kilobits. Sometimes people will say 15 kg they need to bring, but if they bring like 500 gram to 700 gram, 500 gram to 700 gram, allow. That 700 is the upper limit for the excess, which is allowed. So you can say like 8,000 to 10,000. If it is between 8,000 to 10,000, just allow. But here you are saying no, 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 no. I will not allow. Exactly, I allow 8,000 excess kilobits. All the remaining I'm going to drop. You understood? And then we apply this policy map on the interface here for the incoming traffic. When the traffic comes in, you check this one. If it is excess, you drop and accept it. Before you accept what? You check this. And you drop if it is excess, and you accept the remaining, which is within the limit. All right. So this is the summary of the configuration. First you wrote the access list, then you wrote the class map, then you wrote the policy map, and then you applied to the interface. What you saw in the previous 2 pages and what you're seeing here is about policing. Now, to verify, this is the command we type show policy map interface. It will show how many packets got dropped and how many were within the limit. Now, shaping. Read it yourself. Okay, this definition is not complete. It helps to ensure that traffic confirms the specific profile and bandwidth limit. And then what? If it is excess, it will not be dropped. It will be placed in the low priority queue. That is the missing piece. If exceeds the excess traffic will be placed into the low priority queue. AF11 or AF13, correct. Scenario when you want to implement traffic shaping to prioritize voice over IP and video conferencing while limiting bandwidth video stream. Okay. Sorry. You see here, you have written an access list matching some port numbers. These are all the port numbers that voice uses. And then you have another access list for video streaming, HTTP and HTTPS. Then we are calling that under the class map. And then you see shaping. You said that for voice you are putting in a separate queue called priority queue, and then for video you're saying bandwidth of 500. This is the limit that you put. And for those traffic that is coming excess, you put it in a fair queue. Fair queue means the queue that will get created automatically, but this is not high priority queue. You understand? The fair queues are not high priority queue. So this is the nice example for policing. Sorry, shaping. You are not dropping here. There is no drop word here. Do you see any drop or exceed? Nothing. You are setting for video 500 meg and 1000 kilobits and 500 kilobits bandwidth. If this is the guaranteed bandwidth for voice and this is the limit for video, if anything excess comes, and it will be placed into fair queues, multiple queues that will be getting created automatically. Compared to this and this, these queues that gets created automatically are low priority queues. So what it is going to do is it is going to slow down the excess traffic. That's all. Kilobits. That's the amount of bandwidth in the queue, which is always the queue size. You know the queue. The queue, how thick the queue is. How thick the queue is, that much the packet can be accumulated. Voice traffics are very tiny traffics. So for them, this 1000 kilobit is itself is a big space. And this priority queue are the highest priority, more than EF. Usually all EF traffic will be placed inside this priority queue. In class map, here they are matching this access list with the IP address. Instead, you can also match with the traffic which is earlier marked as with the EF, and only the EF will go inside this priority. Right, then we apply that on the outbound of the interface so that it can be shaped. So before sending out, we are shaping it and sending it so that it won't be getting dropped on the provider side. Provider side, they are policy. If you send excess, they will drop. So better you shape it and send so that they won't get dropped. Is this clear? You didn't understand the presentation or my words, my statement. Okay, listen. Here you are seeing what? Out or input? Input or output? This is shaping or policing we are learning. Shaping. Whereas in the policing, if you notice, it is it is what? Input. Who is dropping? ISP will drop your traffic if you are sending excess. When ISP receives traffic from you, that's why it is input, he drops. Whereas shaping, who will do? We only will do. We don't want to send excess and get dropped there. So what do? We do the shaping here and then we send out. You understood this? So this is the summary of the configuration which we have seen in the previous page. Access list, class map. Inside the class map, inside the policy map, you call the class map, and then you set the priority queue. You set the bandwidth for the video traffic, and then for the access, you set the fare queue. At last, you assign it to the interface outbound. All right. So you can read it yourself during the congestion time during the peak hours. Um, if the packets are beyond the capacity, it will be done as per your configuration. Voice will go into the priority queue, video will go into the bandwidth prescribed of 500 kilobits, and all other traffic will go through the fare queue. By doing so, it can reduce the congestion. Yes. Same. You see, instead of in the policy map, instead of setting priority here, you are calling the class map, right? What is this VoIP means? It's a class map which you created here. No, not the access list. What is the name of the class map? You are calling the class map, right? Now here, instead of priority, you can say set. And here, instead of priority, you can say set DSCP EF. And then you send it to the next router. Next router, in the access list, instead of matching the UDP traffics, you will match the EF traffics. The examples are coming later, okay? This is one example. What you're asking is another example. That will come later. In this presentation, you might have seen there are a lot of examples I have put to understand the whole QoS. This is one type of example without marking. All right. So I think I'll